Okay girls, so what we're going to look at today is covalent bonding. Basically a covalent molecule forms when two or more non-metal atoms share their electrons. So if you have a look at the little GIF off to the side, you'll see an example with hydrogen. Hydrogen atom has one valence electron, and ultimately to fill its valence shell it wants to have two. Okay, so what it's doing is it's sharing its valence electron with valence electron of another hydrogen atom to fill its outer shell. So that's pretty much the basis of a covalent bond. What we want to do is we want to fill that valence shell so an atom's pretty much stable. So by sharing their valence electrons, they're able to do this. So when we look at covalent molecules in a minute, we're really only going to be looking at how many valence electrons they have when we're figuring out how their structures form. Okay? Covalent molecules will form in one of two ways. At the moment we're looking at molecules, but we will have a look at lattice structures in a bit. So a lot of common compounds that you deal with, or molecules that you deal with, are covalent. So if you have a look, we've got things like carbon dioxide, water, hydrogen, oxygen, nitrogen, ammonia, your acids, chlorine, gas. So if you have a look at the formula for the compound or the molecule down the right hand side, what you'll see is each of these is made up explicitly of non-metal atoms. So for instance, CO2, carbon's non-metal, oxygen's a non-metal. H2SO4 for sulfuric acid, hydrogen's a non-metal, sulfur's a non-metal, oxygen's a non-metal. So we can tell something's covalent simply by looking at the atoms and saying, are they all non-metals? So the next thing we want to be able to do is draw these structures. So we'll look at two of our most common ones. We'll have a look at carbon dioxide, so CO2, and we'll also have a look at water, so H2O. Now, there's a little bit of working out when we draw these structures, so I'm going to go through what's effectively our working out, and then I'll show you what the finished product should look like. So, you can really start with either of the atoms within it to start figuring out your structure. I normally recommend starting with the atom which is further to the further to the left of your non-metals. So in the case of CO2, we're going to start off by looking at carbon and how many valence electrons it has. So carbon's in group 4, it's got 4 valence electrons. And if you think about carbon, its outer shell can hold 8. So what it wants to do is it wants to get another 4 electrons, basically via sharing. So what happens is our little friend oxygen, just change colour, our little friend oxygen will come along. Now oxygen has 6 valence electrons. And again, what oxygen wants to do is it wants to share electrons so that it gets 8 and therefore it becomes stable. And by getting 8 electrons, you may also hear this come up as what's called completing the octet. Okay, octet means basically completing its 8. So oxygen will come along. It needs to share 2 electrons. What will effectively happen is the oxygen will share an electron with the carbon. So what you'll notice here is now the oxygen has 1, 2, 3, 4, 5, 6 of its own electrons, and it's got the benefit of the one that it's sharing with carbon. So it's technically got 7. It still needs 1 more, so it still wants its 8, so it'll share another electron. So now it's got the 6 of its original plus the 2 from the carbon. It's not completely finished yet, because if you look at the carbon, it's only got 1, 2, 3, 4, 5, 6. So what will happen is another oxygen, because it's CO2, another oxygen is involved in this structure. It will have 1, 2, 3, 4, 5, 6 valence electrons. It too is going to share electrons with the carbon. So what will happen is it will share 1 and 2. So now the carbon has its original 4, the 2 from this oxygen and the 2 from this oxygen, so that gives it its 8. It also has the 1, 2, the oxygen here now has its original 6 and the 2 from the carbon, so it now has 8. So all of these atoms now have a full valence shell. Now this is basically our working out. What we want to be able to do is tidy it up. So to tidy it up, what we're going to do, we're going to draw in our carbon. Alright, now each of these shared pairs of electrons we represent by a single line. So away from the carbon to the right, I've got 1, 2 shared pairs of electrons, so I'm going to have 2 lines, and they're going to go to my oxygen. Alright. On the other side, I'll have 2 lines again because I've got 1, 2 shared pairs of electrons, and then I'm going to have my oxygen here. Now, to finish it off, what we need to also draw into our final product is our unbonded electrons. So what you'll notice is around the oxygen, there are 4 electrons that aren't involved in these shared pairs. We need to draw them into our final product. I've got 4 over here on this oxygen that I need to draw in as well. And around the carbon, what you'll notice is all the valence electrons are actually included in my shared pairs, so I don't need to draw any more into that. And this is our diagrammatic representation of what carbon dioxide actually looks like. We'll have a look at water as well. So H2O, I'm going to start off with oxygen in the middle, and it's got its 6 valence electrons. Okay, and if you're ever unsure, oxygen's in group 6, so it's got its 6 valence electrons. What will happen is, let me just change colour. Hydrogen will come along, it has 1 valence electron. Now, hydrogen only needs 2 valence electrons to be full, so it will share its single valence electron with one of oxygen's. Doesn't really matter at this stage, like you're in year 10, you don't need to know about electron shell repulsion theory and stuff like that to know shapes. You'll learn that next year. But hydrogen will come in and it'll share 1, and now hydrogen has 2 valence electrons. Okay, so the hydrogen is stable. The oxygen, however, it's got its original 6 and the 1 from the hydrogen, so it's only got 7, needs 1 more. So another hydrogen is going to come in. It will have its 1 valence electron. It's going to share that with the oxygen. Now the hydrogen, our second hydrogen, has 2 valence electrons. Our oxygen's got its original 6. Add the 2 in from our 2 hydrogens, and now the oxygen's stable as well because it's got its 8 valence electrons. So we can tidy that one up by drawing in our oxygen. Now, there's only a single pair of electrons being shared off to the right. There's only a single pair of electrons being shared off to the left. So we'll put in our hydrogens like so. I also need to make sure that I account for any unbonded electrons. The oxygen's got 4 unbonded electrons around it, so I'm just going to put them in. Again, shape doesn't matter at this stage. That's not actually the shape that we'd be looking for. The shape we'd be looking for is more of a V shape. If you're curious about that, I'll show you in class. Hydrogen has no unbonded electrons around it, so that's technically finished. Okay, I'm going to get you to practice one and come in ready to have a look at it. So the one I want you to have a bit of a look at and a bit of a try of is CH4. Okay, so that one's what you're going to practice now, and you can come into class and we'll have a look at next lesson. Good job, guys.